in coal mine area with pithead power plant. The second paper shall be from the Department of Mines and Metallurgical Engineering, Pradesh, the West Australia School of Mines, Australia. The authors Brenda Jure and Apurna Ghosh, titled The Application of Groundwater Modeling and Digital Irrigation Mode for Determining of Catchment Area to Convert an abandoned open pit mine into the third paper, presented by from IIT Karachi, titled Geological Storage of Power Development for Energy Sustainability, an investigation of Damodar Valley and Upper Assam region. The fourth paper has a simulation of porous ceramic candle sheet water system from BLO Shaggy, presented by Princess Joy and Virgilio Y. Ladefa from the University of San Carlos, Philippines. This has also been also the fifth paper is a study on determination of life of water and economics of the replacement of conventional water with energy efficient water in coal mines by Amrita Smith from Theory Lab. The last paper is titled Insight of Certified Several Measures against towards production paper of I request all the dignitaries and delegates scientists occupy your respective chairs so that we can join at the earliest. ICOMS 2023. The theme of the session is Mining Innovation, Sustainability, Efficiency, and Technological Impact. The Northern Coalfields Limited (NCL) is a pioneer by ensuring implementation of mining innovation in all its Opencast mines. It has adopted the latest sustainable technologies such as deployment of large-scale surface miners, electronic signatures for blasting, 3D lab laser scanners for survey, GPS-based vehicle tracking system, VTS, and many more. Ensuring sustainable mining practices, the NCL has installed a total of 12 influence treatment plants and 9 sewage treatment plants, respectively, in order to ensure ample quality of water bodies in the region. NCL has also deployed 44 of 20 truck-mounted oxygen to ensure proper dust submission of drinking water in the region. NCL, since its inception, has planted about 2.7 crore plant saplings in the area under construction. NCL has invested in 9 numbers of first mile connectivity projects for clean evacuation of coal, which would reduce dependency of transportation of coal through road. I hope this technical session shall help NCL embrace the latest technology, innovations, and sustainability in its path for the future of the coal mines.
Area General Manager Amlori retired. Sri Alok Kumar Sir, Area General Manager Amlori, has invested in the four private sector from across PRS hearing. Under his leadership, he has set several benchmarks in coal production, coal dispatch, and has ensured time environmental management and community.
I invite the author, Mr. J. John, Mr. Rasila Kumar, sir, Mr. Amarant, sir, and Mr. Sandeep Kumar, to the dais. Take their respective seats. Out of the 6 papers, we have 2 virtual physical papers, one from Australia and the other from Japan. Just because both of them have already joined each other, I request the chairman to start with the second and the fourth paper, the virtual board, followed by the physical one. I now hand over my mic to the chairman for the further proceedings.
Good afternoon, ladies and gentlemen. We are here in the technical session after lunch, and it was scheduled to be started by 2 p.m., but we are already running late, so it has been reduced to 1 hour. So all paper authors are requested to they all are requested to reduce their time to 10 minutes maximum, and they have to finish their presentation within that time. So, first paper, Mr. K.V. George. So, the first author, Mr. George, from CSIR Media, framework for source. Formalities, I will direct topic. Yeah. So, the topic is now. Let me give a few lines. Why this study is carried out? Coal mine is having several types of emission, several sources of emission: coal dump, resuspension, coal dust, then vehicular emission. These are the three major. Right? Then comes the power plant in the nearby vicinity, causing air quality in the surrounding area. So there is a dispute: who is polluting, and one blaming the other. So we need to resolve this issue. How to resolve it? Scientifically, using scientific tools. That is the presentation I am going to do. So in this case, one of the very important factor is define the source apportionment problem. Define means I can pick up receptor anywhere in the coal mine and say that yes, this is polluted because some source nearby. So I have to be very judicious in how to go about it. Then application of different results. Now, you see this is one of the most important diagram I consider for a pit head thermal power plant. This is of Singrauli area near that from top I took photograph. Now you can see there are certain stacks from where this emission is very mild, whereas for some stacks the emission is very dark. So can we say that all the power plants having their ESPs running at 99.9% efficiency, which it claims? It is not the case. Means there are plants which is not working at full designed efficiency, and it may cause pollution in surrounding area. Next, please. Now, how it works? From the stack, if the pollutant is emitted, it disperses in the surrounding area. This is a typical dispersion modeling problem. Everything is well computerized. We have used state-of-the-art CalPerf model. Next. Now, here you can see the emissions from the plant, the coal mining area, as well as stack. So now both are mixing. If the stack emission is well known because of its geometry, we can easily put the numbers in the equation and come out with the concentration in different places. But in the case of coal mine area, the geometry is irregular, and therefore we cannot precisely use the dispersion model. And at that instance, we use the receptor modeling display. Next, please. You can see the same is shown. One is source modeling problem, another is receptor modeling problem. Now, here you can see there is stack. There are several. This is only a schematic. The Full mine is emitting. Where should I keep the receptor, or for which point we need to do the analysis? So what we have done is, one point is at the top of the mine. What is coming? Is it from the surrounding power plant or from the mine activity, whichever is lifted upwards? Things are studied. Now, if I put the receptor location far away from the mining area, effect of mining may not be right. So the question is, well, where are the receptors? Top mine, nearby urban center like Vadan, they can say that full mine is causing problem. Since it looks big, they are always blamed. But power plant also, the emission is visible, they are also blamed. And I have spent most of the time in sectors on power plant and coal mine. So what are the likely sources? The four sources are given. Next. Now here is the dispersion modeling problem. We use meteorological data, emission inventory from stacks and solve it. And you can see the W shaped, these are the 10 mines and near the Rayan Dam. On right side you can see 1 kilometer grid. Since this area is highly undulated topography, because of the overburden, we have chosen very finer grid. This is the finest form available, 1 kilometer of grid size for deciding meteorology. This is the typical non-uniform wind flow. So if someone says that wind is flowing in some particular direction, no, it spatially changes. Next, you can see for certain time of the year there is a predominance of wind. Summer season, the wind is from east. During winter season, a part is the west, southwest, west. Or during rainy season, it is from the south, west, all. The combined is shown the first figure, that is annual meteorological. Next, these are the mines, and you can see the power plant just located there, and those pins are the points which are CEPI sites. Now, besides mine top, these CEPI sites are the important because CPCB measures air quality at these locations. We need to know whether these locations are influenced by the power plant emission or not. That I will show. Right? These are all the emissions from different stacks. You can see some 42 stacks in this area, which is all mapped. Now, this is the output of the dispersion modeling problem. You can see those contours that shows the concentration, ground level concentration of pollutant. Now, this is with an assumption that ESP is working at 99% efficiency, which may not be the case. It not be the case, and regulatory compliance is daily average. So, in 24 hours, we need to have one value. You can see the maximum concentration goes around 110. Next. Now, if we reduce the timing on 3-hourly basis, the concentration goes up. So at some time of the day, in the vicinity, the concentration is very high. Therefore, you can see when the concentration is high, it may be complying with the regulatory norms, but not with the instant numbers. This is for 1 hour average, the concentration is very high. Now, these are some of the things which regulatory mechanisms overlook. Next. This is when the 98% efficiency of ESP is available. In that case, you can see the concentration. Next. Next. In my observation, most of the ESPs are working at relatively lower efficiency, and this may be the case. So, concentration is very high at some of the instances, which adds to the concentration of coal mine area and creating trouble. Next. Now, this is something very important. You can see there is one CAAQMS, Continuous Ambient Air Quality Monitoring Station. This is at Suryakiran Bhavan. You have the south side, two power plant, 2000 megawatt, 2007 megawatt. Now, how these power plants influencing the data in ICOMS station? Next, these are the values obtained at the ICOMS station, PM 2.5, 10. They are all exceeding. Next, here you can see, now this is the data of all stations in Madhya Pradesh. Here you can see Surikaran, Singrauli, that is somewhere, this is exceeding in very high number, PM 10 and 2.5. So what is happening here is, your ICOMS station is just downwind of the power plant. So this is bound to be influenced. Next, this is sulfur dioxide and nitrogen dioxide. Here you can see again, these are the two. Singrauli is the only area, Suryakiran Bhavan, where it is exceeding. Again, next. Now, whether there is any bias in the data, you can see SOX and NOx, they are correlated. There is, I can say, no manipulation, data is fair. Next. Now this is again very important, polar plot. The first diagram you can see the red hotspot. That shows. Now this is having three axes. One is direction north, south, east, west. Another concentric circle is the wind speed, 246 meter per second. Now that red spot is at a point where the wind speed is 3 meter per second. And it is coming from east, south, east. And red color shows the concentration is 140. So this is what is the concentration, hourly concentration coming from the power plant for sulfur dioxide. Now on the right side you see it's a frequency diagram which shows how frequently it happens. You can see on the the legend top is red color 200. So maximum hours is coming from that power plant. So this confirms how the power plant is influencing our station. Now in this way we have collected samples. You can see the numbers, particulate matter sample from different stations. Next. These are all the stations where we monitored the sampled particulate matter for chemical analysis. They are the sampling station past. These are all these chemicals, the stations where we collected. The filter papers are taken to our laboratory in Nagpur. We do analysis, different analytical equipments. Now this process is bit tedious. That's all. One of the reason is those who are working in the lab.
Judge sir, conclude.
Yeah, coming to lab. Here they are all exceeding numbers. Fast. These are the signatures of the PM10 and 2.5 overburden and plus vehicle. You can see signatures we have created for all the sites for the fly ash. Here you can see fly ash shows altogether a different signature. Next. Now here you can say mine top. The concentration or the pollutant signature that we get at mine top, it is having 81% influence, not the mass fraction, influence of 79% influence of overburden, not the fraction. So next, there is the cluster analysis to show. You can see on the right side, all vehicular emissions are together. We have collected several samples. This establishes that signature profile is done fairly well. Next, this is for different sources, the PM 2.5. Next. Now I'll show just few slides for the receptor modeling tool. These are all the mathematical expressions. Next. Now here you can see for SEPI side, mine top side, we have done so many runs. These are all the hyperparameters to establish whether the runs are correct or not, satisfied. Now this is coming to conclusive level. We have got four factors, four sources. Now how forces are connected, you can factor one is identified as overburden. Last line you can factor is identified as vehicular emission. Next. Next. You can go fast. Now these are all for different particles, different sizes. This is the pie chart of what is contributed. Fly ash contributes 37.5%. The PM10 AP area in mine top, fly ash is contributing 23%. These are all done scientifically. Next. Next. These are the tests to establish whether we are doing the run correctly or not. Statistical tests, all are okay. Go ahead. Go ahead. Now, yeah, conclusive slide. In this area, both at the top of the mine, or in this vicinity, power plant is having a significant contribution. It's visible. One of the technique which we are suggesting is of visual emission observation. I was on a 1 week training in the US for how to do this. Now today, since artificial intelligence has come, you can use a camera to monitor the top of the stack and say whether ESP is working at particular efficiency 99.9 or not. From here, already we have started working on that, not in a project mode, but just because of our interest, and we will come out with our results with NCL. And lastly, this is our team. Thanks to all of you. If you have any questions, come forward. I should say that First time I saw a coal mining kind of a big institution is willing to engage in this kind of activity, because this activity is relatively sophisticated compared to first mining activity. Thank you, sir. Thank you very much.
Very good presentation. So, have you checked running up ESPs during the time of your study?
Okay, sir, I have checked, not here, but I know when yes, running at 99.9% efficiency, how this smoke appears, how this looks. Here, the dark, very dark smoke, ESP is not working. Now, when ESP is not working, no power plant will allow us to enter it. Nice. Yes.
Okay, thank you, Mr. Jas.
Thank you,
So, our next author is from Australia. Link up हो गया है दिन का? So, I welcome Mr. Ayanda Dubey, Apurna Ghosh from Australia. Their paper is related to application of groundwater modeling and digital elevation model for determination of the catchment area to convert an abandoned open pit mine into an asset. So, Mr. Ayanda, you can go ahead. So can you hear us? So 10 minutes are allotted for you. So you can start right now. Okay, please. Please unmute your mic. You are not audible to us.
Can you hear me now? Okay. Okay, I'm not sure if you guys can hear me, so I'm just going to go ahead and start. If there's a communication error, can someone just put in my inbox that you cannot hear me? I just need confirmation that I can go on.
Yes, go ahead, please.
You can hear us.
Okay, thank you. So like I was saying, my name is Ayanda. I am a graduate mining engineer at Curtin University. I did this research with Dr. Apuna, who's a lecturer at Curtin University, Western Australia School of Mines. I'm going to share with you a screen because I'm not quite sure what you guys can see and what you cannot see. So I'll just give you what I have. So the title of the thesis was called Application of Groundwater Modeling and Digital Elevation Models for the Determination of the Catchment Area to Convert an Abandoned Pit Mine into an Asset. So generally, Western Australia is known for its mining habits, specifically open pit. And also, on the other hand, it is known for its arid region, which suffer from scarce water resources. Are you waving because you can't hear me?
Could you make it full screen, please? The screen? Could you put it in the presentation mode, please?
Perfect. Great. So this issue normally in bigger cities and towns in Australia, normally the city council provides boreholes or supplementary water. But in cases of remote areas, this becomes a challenge in the sense that PPT on full prompt. Sorry about that. In cases of remote areas, this becomes an issue because there is no one to provide this water source. So we came up with an idea to try and make use of these pit lakes that are already existing from all the mining activities that is found in Western Australia. Though this is not a fresh out of the box idea, because in the past people have studied pit lakes, but only for the cases of risk management and all the other negative impacts. So this particular research was to try and find and address the gap in exploring the advantages of converting pit lakes into assets. So today I'm going to specifically just outline the problem as being the shortage of water in Australia, and we want to take advantage of the fact that we have all these pits that have been abandoned that we can convert to make as a water resource. So the objective of this whole research was to estimate the amount of water that could flow into a potential pit lake, which we'll call pit lake X, for example, and how we are going to achieve that. That was achieved by establishing the catchment area of the region, investigating the contributing ground features and their interactions with water, and then assessing the hydrological features and any other systems and controls around the area for us to be able to say, is it sustainable to use this pit lake for water systems? So the deliverables that we wanted to get at the end of the project were the catchment area size, which was measured by survey, and the quantity of water that we could store in the pit lake. So the reason why this was important is because of legislations and policy issues. If we're going to propose reusing mine water, for example, we will have to file in for licenses and stuff like that. But the lawmakers or policymakers need to understand the quantities before we can proceed. So to achieve this, we needed 3 key resources. The first one being the pit lake information, which was the location of the pit lake, the size of the pit lake, and the observed past performance of these pit lakes. And then in this case, we also used GIS. And then for the modeling tool, we made use of ModeFlow 2005 package, or specifically called Model Moose. This was used to model rainfall patterns, drainage, project mining rates, pumping rates, aquifer attributes. So we factored all those hydrological principles into the model so that we could quantify it properly. Right. So this study area was a remote area in Western Australia, where it's approximately 600 kilometers from a big city, which is Perth. So it's a very remote area, but this area was of interest because it was involved in the 19th century gold rush. So this was a time when the gold mining was at its boom in Australia. So there was a lot of mining activity, open cut mining activity. So a lot of these open cast mines, pits, were left unattended, or they were left under just the rule of mine closure. So we have these already available. So the place of interest was selected because there is a vast number of pits in that region. So like I explained, this was to address the issue of aridness. This is a high temperature area of 32.7 degrees to 37 degrees on a normal year range. with humidity peaking at 68% in July and goes down to 41% in December. So as you can see, the average annual rainfall in this region is only 265.1 millimeters. So we picked out a methodology for this investigation. So the first one being data collection, and then we did a digital elevation model. We constructed a finite element model, and then we created a validation program to try and see if our finite element model was reasonable. And then later in this presentation, I'm also going to talk about the results and the conclusion. So like I explained in the previous slides, for us to come up with the digital elevation model, we had to create side polygons from Google Maps, which were then imported into Earth Explorer to establish a 2D digital elevation shape. Then we took this to GIS to then analyze the anomalies, find if there are any sinks that have been captured by the cameras, and then smoothen that out. And then we ran GIS to then evaluate what the catchment area be. And then the next step was to create a finite element model. This was done by then taking our 2D digital elevation model and setting it up at Model Moose to then define our grid in a 3D system that shows us the pit and its surrounding features, which in this case we were mostly interested in the ground elevations around it. So with this, we then use the rainfall data, the evaporation data, and all the geological properties and hydrological properties in the region to come up with what you see in the image there, a 3D model with 3 layers at a depth of 250 meters. So after doing the final elevation model, we had to compare our results with something because none had been done in this region. So that's how we came up with a model validation program using the same assumptions as we used in Model Moose, but we created we did a manual design based on the principle. Sorry, my time slot is over. I'll just rush through it. But basically, what we found at the end of the day is that we could actually harness these pit lakes and get water out of it. From our general elevate search, we found that we could have our lake fill up to twice at the end of the year, and thereby giving up to 149,000 square meters at the end of the day. So, but because sorry, I'm just rushing through it now. Pretty much because we had limitations to this, there is a lot that was not covered, and we recommend that further investigation in terms of verifying mine data, measuring and surveying be done and carried out in the future. Thank you.
Thank you very much for your presentation. Okay, we look forward to your visit, possible to India, so that you can see some of the Indian abandoned pits. Okay, thank you very much. Next, Brusti sir.
Namaskar, good afternoon, one and all. First, before I make my slide, before I start my presentation, I would like to convey my thanks to the ICOMS Organizing Committee and the NCL Authority for giving me these opportunities. Slides, please. So I am Professor B.K. Prishti, an associate professor in the Department of Mining Engineering. I am basically teaching the subjects of environmental control in mines, including I also teach one subject called sustainable development of mining industry. In every year I am also offering one short-term course on the same topic, and also my experimental research consists of the uh, absorption studies of methane and CO2 for coal bed methane, shale gas recovery, as well as the geological carbon dioxide sequestration, the geological formations like coal, shale, and other metamorphic rocks like basalt also. So this is my presentation. The title is Geological Storage of CO2 in the Damodar Valley and Upper Assam Basin. Next, please. Okay, so this is the outline of my presentation. I will first introduce the topic, and then we all know about the importance of the climate change as well as the sustainability issues, and what are the technical solutions. One of the technical solutions which is available as it is the geological spaces, and how we can sequester this CO2 in the gas shell deposit. So some experimental study we have done about the CO2 storage in our gas cell formation. There are so many gas cell basins that is present. I have only here I am presenting some 3 samples they are taken from the Assam cell, Assam basin as well as this Damodar Valley basin. Next, please. So we know that because of this climate change issue, that why after this industrial revolution, how this global average temperature has increased more than 1 degree centigrade, and we are seeing consequences. So our government of India is pledging for as per the Paris Agreement, to target our global rise of temperature degree centigrade, and if by 1.5 degree centigrade. So for that, we have to go for the decarbonization, or what is the carbon neutrality. Now there are different ways how to achieve the carbon neutrality, but one practical solution where technology is existing is that we can inject or we can dispose our CO2 into various sinks, and there are several sinks are available, but one uh, very promising sink is the geological formation, like the abandoned mines or like the deep oil and gas formations. So these are very practical um, um, alternatives where the technology is existing, because this oil and gas industry, they are using the drilling, they have the drilling technology, they have the injection technology. So those technology can be used for CO2 injection into the gas cell formation. So as you know, this gas cell formation, they are shale deposits which are occurring at very greater depth, like 3000 meter, 3500 meter, like that. And our oil and gas industry, they are exploring what is the shale gas reserve. So there are several basins. Next, please. Next, you can go to the next. So one more slide. There is a, so you can see there are several basins that is present. You can say Assam basin, Damodar basin, Satpura, Reva basin, Kambe basin, Krishna Godavari basin, and Kaveri basin. So there are several basins, very prospective basins, which contain lot of shale gas. So one, because we are moving from the fossil fuel, particularly the focus is on how to move away from the coal in the energy basket. So one alternative solution will be that we use more of natural gas. So apart from coal bed methane, this shale gas will be a very the next target. If we can if we can recover the methane and use it, then it will be relatively cleaner compared to the solid fuel. Go to the previous slide, please. Previous slide. So here we have done the absorption study. Absorption study means how much CO2 gas this gas cell formation they can store, because if you inject the CO2 for the CO2 sequestration, there will be double benefit, two benefit. One is that we can produce some extra methane, that is known as the enhanced gas recovery. You can produce some extra methane or shale gas, and at the same time we can store the CO2, which will be helpful in the CO2 sequestration. So this will provide a good solution, win-win solution for this one. So, but for that we have to characterize your gas cell formation, that how much is the methane storage capacity, how much is the CO2 storage capacity. So one way which we do is by conducting the absorption isotherm study. So we have here in this study we have taken 3 samples, two from the Assam sample, that is the Assam Basin vacuum coal field, and one from the North Karanpura coal field. So these depths are given. Next slide, please. Next slide, please. Next one. So this is the experimental study. You can see a figure of a high pressure absorption isotherm setup. This is basically a volumetric method, or we call the manometric method. So here you have the one sample cell where you pulverize the sample, whether it is the gas cell or the whatever it is, powder sample you put it, and in the reference cell you fill with the absorbing gas, let's say CO2, and you can, by exposing the cell sample to the CO2, you have to measure the pressure of the sample cell, so you can calculate how much gas will be absorbed. That is what we have done it. Next slide, please. Next slide is the procedure. The time is not there. So now you generate the experimental data, that at the different pressure, what is the gas storage or what is the gas that is absorbed. So pressure versus volume absorbed data that you determine by using the experiment. Then you plot it. Then you plot that volume absorbed data to get what is known as a isotherm. The experiment is conducted at constant temperature. So that is why it is known as a isotherm data. Next slide, please. So this is how you can see, this is isotherm, that at the x-axis you have the pressure or the megapascal or bar. Normally CO2 we go up to 70 bar, because around 67 bar we have the supercritical condition, and we can also go beyond 70 also. So then it is called supercritical CO2. So you can see that in the x-axis there is the pressure in the bar or megapascal, that is 80 bar or 8 megapascal, and on the y-axis what is the absorbed volume up for each pressure. So you might have seen the isotherm for coal, it will be relatively higher quantity because the organic matter content of the coal is high, so the absorption capacity will be less. But for gas cell, where the organic matter content is very small, 1%, 2%, maybe 3%, so you will see that the capacity is very, very less. But nevertheless, this is the isotherm. You can see that the way we are doing the experiment, when we are increasing the pressure, the absorbed volume is increasing, but going to a maximum point, and then it is decreasing. So physically, if you think it should not decrease. So why it is decreasing? So that is the explanation, is that as we are measuring and we are calculating, it is we are measuring what is known as the excess absorption. So excess absorption, it is not considering the change in the density, because when the absorbed condition, the gas is being deposited on the in the pore spaces, there is a absorbed phase density that is increasing. We are not calculating. Because of that discrepancy, we are seeing a decreasing trend. So that's why you have to calculate what is the absolute isotherm. Please, next slide, please. So this, by using this equation, n absolute equal to n ex experimental divided by 1 minus rho for gas phase density of the gas divided by the rho absorbed. Rho absorbed is the same gas is absorbed and the density is very high, liquid like density. So you by this you can calculate the absolute absorption. Now that isotherm I will be showing, but then see, this absorption experiments are very expensive. You have only limited sample that you are getting from the exploratory drilling program. So you want to predict what should be the, if I have a cell sample, what should be the capacity. Then you have to use some equation or model, absorption model. So here, next slide please. So here we are using, there are several equations or models are available, like Langmuir model, which is the monolayer, which is based on the monolayer theory. One, there is PET isotherm model, which is on the basis of the multi-layer modeling. Similarly, there is another equation called DA equation or DR equation, These are on the basis of the pore volume filling theory. Okay, so you have used that SDR, or that is the supercritical Dobinin-Radulescu equation to predict what will be the isotherm, what will be the adjoint volume. So here you can see that the lower curve, that is experimental data. So experimental data we are modeling, that is the excess data, and from the excess data which is experimental, using the previous equation by taking the density, we are calculating what is the absolute data which is on the top. So you can see the absolute absorption is almost at higher pressure, 2 times the excess absorption data. So conclusion, next slide. So here, just to, because time is already I have been warned. So to summarize, we have taken 3 samples. Actually, we have carried out several experiments. Here I am showing 3 samples, and using the 3 samples, we have measured the CO2 absorption data. So CO2 absorption data, as it is measured in the experiment, it will give the excess absorption or gives excess absorption data, which is actually not very accurate. So for accuracy, you have to convert it to the absolute absorption data using some equation which considers the that decreasing pore volume and also the increasing adjoint phase density. So we are doing the correction. By doing the correction, we are calculating the absolute absorption data, and then we are using several equations. You can use, there are several equations are available, or models are available. Using the model, you can convert, you can predict what will be the absorption at for a sample at high temperature, high pressure. Okay, so this is the data, and thank you very much for your patient listening. If any question is there, I'll be happy to take those things.
Thank you very much. Next, Mr. Amritansu. आप सीधा टॉपिक में आ जाओ, फुल इंडस्ट्री के बारे में ज्यादा मत बताओ, सीधा मोटर पे आ जाओ. हाँ.
My research and findings are basically divided into parts to determine of type of induction. I will be that studies have been by the life of motors have been decided. The motors we use in our next slide. Induction motors, as we all know, they dominate over other types. Their reliability, construction. These are the reasons that they have been popular in not only our industry but overall all the. Because over the past decades, the number of induction motors that have been a large, and we all know that they are the major components of electrical, up to 70% of the electricity. We all know that induction motors are basically categorized in types, mainly there are spiral cage induction motors and spring induction. Both of these are widely used in our coal industry. Spring motors are widely used in duty cranes, shovels, and spiral cage induction motors are widely used in our coal handling. Thus, there is an important task to determine the life of induction motor. How and till what time these induction motors, these becomes a definitely important task for all of us, because in our industry, the timeline for the replacement and the survey of according, we along with our PMPDI have done a extensive study on this. Induction motors majorly in coal mines are characterized as HT and LT. We have done a study of HT motors, cast underground, that are FLP motors. While the HT motors are operated at 6.6 kV and 0.3 kV operating rates, and they are referred as LT motors. So here we can say that LT motors will have a less life than HT motors, because the current drawn LT motors are a higher magnitude, and therefore installation stress case of motors are high, hence they have a next. these are the sample data that we have studied. We have done a study of motors from various subsections of CIL, such as SECL, CL, and CL, and a sample study of 100 motors have been done. This what we have observed is that motors which are continuing in operation and their life is less than 15 years and they are till date they have not been repaired, or they say that they are working in fine condition. That number of motors, number of motors that have been repaired years and they are still working, number of such type of numbers, and motors were there in the industry where the motor life was between 20 years and they were still in operation. And 7 motors life was between 1 to 5 years and they were working. They were in working condition, but they have gone multiple repairs and multiple rewind. Next. Accordingly, this pie chart shows that a majority of our motors are working with or without repair up till 15 years of life in the case of HT motors. This is a graphical representation of the previous data only. So in this what we can say that the majority of motors that are working with a single rewinding or without any repair up till the 15 years of. Accordingly, same is done with the LT motors. Here LT motors, as we all know that LT motors will have a reduced life high because the current in the LT case is very high. Accordingly, sample study with 136 motors was done. Here the number of motors, type of motors that was less than 10 years and they were working in fine conditions without any repair was 43 numbers that we have analyzed. Number of motors that have been repaired with 10 years and working, that was 57 in numbers. Number of motors that have life 11 years and they were working multiple repairs were 23 in numbers, and the number of motors that have a life 15 to 20 years and were working multiple repairs, that were 13 in. So accordingly, in these 136 samples, what we have analyzed according to the life that has completed and they have been working without repair or working multiple repairs. Next slide. Accordingly, in this pie chart, what we have done is we have summarized the data, and here we can see that the majority of motors that have been working in our industry without any repair or with multiple repairs is basically of below 10 years. Next, please. So based upon these data, what I have summarized, we have projected the life of HT motors to be 15 years, backed upon the sample study that I have shown, and the life of LT motors to be 10. This was the first part of the slides. Next part is that next please. Next, the replacement of conventional motor with energy efficient. As we all know that HT motors have a high percentage of efficiency. In LT motors, we have an international efficiency classification. I1 type of motor, I2 type of motors, I3 class, I3 class, I4 class. Presently, conventional motors, mainly I2, are used in full industry, but energy efficient motors, I motors are commercially available up to 355. As a part of energy efficiency drive, in view of reducing the energy consumption in industry and making it more energy efficient, study has been carried out to find the technical commercial viability for the existing LT motor to be replaced by energy efficient. The following formula has been considered for deriving the payback period and replacement of existing motors with energy efficient motors. This payback period has been derived. The average payback period is what we have done is we have taken the price of I4 motors. The replacement which we are doing the motors, say we have an I2 type of LT motors, say after 5 years we are replacing it, and we are assuming that after 5 years what residual value is left, we are not going to get that also. We are also seeing that it the capital cost of IE4 motors. So the formula comes out to be IE4 price plus residual value of old metal plus difference of RMS repair and maintenance. What is that? Why you will have to think repair and maintenance cost, and the old motor also will demand a repair and maintenance cost. So I have taken the difference of the repair and maintenance cost divided by the annual energy that you will be getting upon replacing the IE. So this is the formula that we have used to derive the payback period. Next. So this is a pictorial representation of the difference in efficiency of IE2 class motors and IE4 class motors. In our coal industry, we predominantly use IE2 type of motors. From this graph we can see that lower rated kilowatt motors, there the efficiency difference is high, and as the kilowatt of motors increases, the efficiency difference tapers. Next. So why IE motors are having higher efficiency? There are a few design aspects of IE motors. They are manufactured by high quality metals, alloys. They optimize the even air gap between rotor and stator. They can withstand high temperature. They have low failure rate. Next. So the average payback period, considering the average payback period, what I have shown, I have drafted an Excel sheet for calculation regarding the replacement of energy efficient motors. Next, so the Excel sheet, same fold, data. Yes. Here what we have done, we have taken the IE2 motor. We have taken the IE2 motor. We have calculated the difference. Then we have considered the IE2 unit price, IE4 price, IE2 energy consumption, IE4 energy. Then we have calculated the hourly. Then we have annual running hours. We have multiplied that. We have taken out the energy saving annually. Then we have calculated the residual value of old motor. Say we have used the motor of. We have calculated the residual value, and we have loaded in that into the cost of IE. Say we cannot survey of, and accordingly the difference in repair and maintenance cost, and we have calculated the payback. Here you can see that the payback period calculation, I have used the tariff. Say in the command areas of Jharkhand, the CCL, the tariff comes around 7 around. Here in MP, we have a tariff around 12 rupees. So the viability will be higher in MP and Chhattisgarh or Maharashtra because of the higher tariff. The average payback period, if the payback period is more than the life, then you can go for the replacement. And if the payback period comes greater than the life of the motor, then you cannot go for the replacement. You have to wait for the completion of. Next slide part. So I have summarized that table based upon the tariff that we are using. Replacement at a life of here 10 years, and for tariff 8, 9, 10, 11 and 12 rupees. I have summarized the replacement. Next. So in this, what we can infer is that motors which have completed their scheduled life shall be replaced with energy efficient motors. For various other tariffs and life, the payback period shall be calculated from the described table. NCL pays its electricity bill at a high tariff, around rupees 12 per unit. The payback period for replacement shall be economically viable at such a high. Thank you.
Very good. Sir, संजीव कुमार, आपने क्या डाटा दिया ओपनकास्ट माइन का था कि अंडरग्राउंड का था? कौन सा? CCL, ECL की CCL? गुड स्टडी.
Myself, Sanjeev Kumar. I am going to the paper which has the title site of fight year regulation become related to just related I I next is deep comparison of full and suppressed year regulation 2010 and fights. 20 new regulations have been added. 4 new chapters have added regulations related to additional requirements for renewable generation, electricity charging, direct payment, and for gas related services. 2 schedules have been reflected in new regulation. Next. Now come to regulation 104, which is related to voltage limits at open cast mine. At previous regulation, it was written as electricity shall not be transmitted into a mine at a voltage exceeding 11,000 volt and shall not be used therein at a voltage exceeding 6,600 volt. Now, in new regulation, the word underground has been added before the word mine, and its fact is that the restrictions of transmission and use voltage have become limitless for open cast mine. Now the mega projects which are having higher capacity electrically operated HEMMs and facing the issue of poor voltage regulations existing of more than 3 km long length of electric feeder of 6.6 kV shall have following advantages if 33 kV electric distribution line is laid near the electrical load area with provision of modular 33 by 6.6 kV substation. First, good voltage regulation. Second, lesser distribution loss in overall resulting in saving in electricity bill. Third, requirement of lesser size of conductors. Fourth, occurrence of lesser breakdown in operated line. Next. Next, regulation 109, which is related to flexible cable at open cast mine. Now, the HEMM of open cast mine, like drag line, sawell, could be connected with 600 meter length trailing cable maximum, which was not possible with earlier limit of 300 meter. This will provide a lesser frequency of shifting of electrical field switch, which will ultimately increase the productivity of mine. Next. Regulation 100 is related to lighting, overhead lines, communication, and fire precautions. Same as old regulation, except addition of fresh lines that where dumper bucket in raised position, the clearance between the top of the dumper body and to the lowest conductor of the overhead line or overhead cable shall not be less than 1. This amendment shall enhance the safety of electric distribution line and HEMM in mine. Next. Regulation 110, which is related to portable and transportable machines. Now the field switch meant for feeding the power supply to HEMM could be switched on or off from operator cabin of HEMM. This will prevent the undue delay in switching on or off the HEMM from the field switch. This will enhance productivity. Next. Now it is Regulation 107, which is related to disconnection of supply. Now it is statutory to install and commission voltage relay have automatically disconnect the power supply through switch gear in case of under voltage received at any motor in mine and at switch gear of feeder at substation. This shall address the problem of occurrence of low voltage in any feeder and machine for design and system of equipment used at distribution electric line in mine. Next. Regulation 103, which is related to protective equipment. Now the earth fault current will have to be limited by 10 ampere. Previously it was 50 ampere in every electrical installation existing 1100 volt in open cast mine by installation of NTR and neutral ground system and between 200 to 400 milliampere for individual electrical apparatus up to 1100 volt. This shall enhance the electrical safety of mine and machine in mine Further, daily record of substations is to be recorded electronic also, and checking and calibration of switchgear and protective devices at least once in a year. Previously, it was every 3 months. This shall enhance the overall electrical safety of person working in mine. Next. Regulation 118, which is related to training of personnel engaged for operation and maintenance of electrical installation in mine. This is the new regulations added in Regulation 2023 for training of personnel engaged for operation and maintenance of electrical installation in mines, with direction to impart refresher training at a periodicity of intervals not more than years for enhancement of electrical safety. Next. Regulation 98, which is related to notice, same as old regulation except addition of fresh lines that in case of emergency, which may lead to loss of life or machinery and is detrimental to safety of mine, intimation shall be given with 24 hours to the electrical inspector of mines, giving the healthy apparatus along with self-certification if such additions or alterations are taken. This modification regulation will empower the mine management to act promptly in case of any emergency. Next. 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 Thank you. Any questions?
चलिए आपने अच्छा मेहनत किया है, एटलीस्ट हम लोग का एसओपी मॉडिफाई करने के लिए थोड़ा जुगाड़ मिल गया है. थैंक यू वेरी मच. आप लोग सुनिए ना, टी ब्रेक में कर लीजिए, बिकॉज आवर गेस्ट फ्रॉम फॉरेन इज वेटिंग ऑन द लाइन. हाँ, पुट हिम ऑन द लाइन. We understand that he is not connected and video is available, so that will be displayed whenever we get a time. I think our chairman will give his opinion. What to Pandit Sahab?
Now I request the rapporteur, sir, Shri Alok sir, to kindly summarize the session.
Good afternoon to all. Overall, 6 papers were there, 5 were presented. All were very relevant, informative, and forward-looking papers. The first paper was presented by Mr. K.V. George and his team from NIRI. It was a very scientific and technically rich paper. The author talked about various types of emissions in an area that has a number of coal mines, thermal power plants, and Varanasi city also. Then how to define the emission proportion was the main motto of the study in a scientific manner. And the author and his team used dispersion modeling for this study. And I think this will go a long way in designing and adopting pollution control measures in future for sustainable mining in this area. Second paper was presented by Ayanda Dubey and co-authors from Australia. The font, I must say, the font was very small. I could not see much the slides, but I could gather that it was about a study of pit lakes through groundwater modeling and a digital elevation method to understand how an abundant open pit water can be converted into an asset for use by community and wildlife, etc. This was all about using water resources in the catchment area efficiently for the community. The third paper was presented by Sri Basant Kumar Prustiji from IIT Kharagpur. The author talked about CO2 storage in context of climate change. He also talked about use of technologies for carbon storage in different basins through a absorption study on gas cells. This study will help in creating CO2 sinks, which will contribute towards reducing the impact of climate change in future. The fourth paper was presented by the author Amritanshu from CMPDI Ranchi. The study is about determining the life of induction motor and how the economic works. As per the study, he could find out that the projected life of induction motor ST motors was about 15 years, and for LT it was 10. The study also goes on to define the energy efficiency motors by calculating the energy saving per year and the payback period. This will reduce the electricity traffic tariff as well as will make the company and operations more energy efficient. The fifth paper was by Mr. Sanjeev Kumar from NCL headquarters. The author presented a comparison between CA regulations 2023 over CA regulation 2010. It was indeed a very informative paper which will help in betterment of the mine efficiency and productivity. Thank you.
मेरे को पृष्टि जी आपका पेपर देखने के बाद मेरे को याद आया जैसे got more than 400 wells CBM wells in सुहागपुर लालपुर एरिया में, वहां से रिलायंस ने वो टैपिंग करके CBM बेचता है. CBM निकलने के बाद तो वो तो पोरोस हो जाएगा अंदर, उसमें भी CO2 डालने का कोशिश कर रहे हैं क्या आप लोग? आप उनके साथ संपर्क में रहिए. 450 वेल है, एकाध सौ तो उनका बंद हो गया होगा.
आपका जब प्राइमरी मेथड में जब गैस प्रोडक्शन हो जाता है तो धीरे धीरे प्रोडक्शन कम हो जाता है, हार्डली 20% 25% रिकवरी होता है. तो at that stage you can inject CO2 and get some extra methane recovery. Okay, and that is known as the enhanced coal bed methane recovery. So normally in other countries that is the practice. They inject CO2, get some extra CBM, and then that CBM also can be it can be staying there for a long time. That is also considered as the CO2 sequestration.
Very good. तो आप उनका जो हेड है, हेड ऑफ दैट यूनिट इन सुहागपुर साडोल, इज ए माइनिंग इंजीनियर एसके सिंह. आप उनका संपर्क में रहिए, ही इज वेरी पॉजिटिव. तो उनसे रहिए, ये सब कुछ करिए यहाँ आके.
ठीक है, इसके साथ से कांटेक्ट करो.
ओके ओके, थैंक यू सर.
So it was a very nice session, and of course very heavy up just after lunch, and my all authors have presented so nicely, and let us conclude it. Over to the organizers.
Thank you, sir. Thank you, speakers. It was indeed a wonderful session with you all. Now, I request the chairman of the session, Sri A.N. Pandey sir, co-chairman and the rapporteur, to kindly felicitate the authors with the seminar with the mementos. Sir, kindly come forward. I request Chairman of Session Sri A.N. Pandey sir to felicitate Sri K.V. George sir, CSIR Neri. Please have a huge round of applause for Sri K.V. George sir. I request co-chairman Professor G.K. Pradhan sir to kindly felicitate the author of the session with memento, Sri Basant Kumar Prustiji sir, IIT Kharagpur. Please huge round of applause sir. Audience, please. I request the rapporteur Sri Alok Kumar sir to kindly felicitate the author with memento, Sri Amritanshu sir, CMPDI Ranchi. I again request the rapporteur Sri Alok Kumar sir to kindly felicitate Sri Sanjeev Kumar sir and Skill Headquarters.
Now I request Harish Duhan sir, Area GM Nigahi, to kindly come to the stage and felicitate our chairman sir N. Pandey with memento. Sir. I request PD Rati sir, Area GM Block B, to kindly come over to stage to felicitate our rapporteur, Alok Kumar sir. Sir, please. Let's have a big round of applause for the rapporteur of the session. So thank you all. So we will be concluding this session, and we are actually starting the next session due to the paucity of time. So our next section on the technology-based environmental management and resource planning shall start right now.
Thank you, Vijesh. So AI is everywhere. At the starting of the day, when we first see the mobile phone screens, we start our day with the AI. And now AI has started spraying its impact into the entire operation chain in the mining industry as well. And environment management is one of the key area where it has made a very significant impact. Being part of the technical team, I was presented plenty of great papers, but I must congratulate this house that we have received maximum papers into the environmental section. A huge round of applause, please. Wendell Berry has said, the earth is what we all have in common. It is our prime duty to ensure the environmental protection while also ensuring that our economic aspirations are not taken a second step. In this session, we are having 5 papers. I would be calling authors first. Shri Subhajit Banerjee sir, kindly come on stage for the presentation on improved resource management, the ERP solution for sustainable mining. तालियां नहीं बज रही हैं, काइंडली शाम हो गई है, पार्टी की बात आने वाली है, लेकिन तालियों की आवाज नहीं आ रही. पीछे वालों से मुझे कंप्लेन है. हिमांशु दुबे सर, आप दिख रहे हैं मुझे? प्लीज जोरदार तालियां बजाइए भाई, एनर्जी कम नहीं पड़नी चाहिए. नेक्स्ट ऑथर डॉक्टर सौम्य रंजन मलिक, presenting his paper on assessment of air quality in residential areas around an Opencast coal mine, a case study. We have third in-house technical head coordinator being an author for a vision statement for CIL strategy contribution for 5 trillion economy, Atmanirbhar Bharat. Mr. Pradeep Kumar Tripathi, I would request kindly take a seat at the stage. As rapporteur of the session, we have our own PD Rati sir, Area General Block B, who has been a very backbone of the ICOMS for the previous session. Sir, kindly take your seat at the stage. As co-chairman, we have Deepak Saxena sir, who has been a mentor for this entire program. Kindly please take your seat. As chairman, we have Harish Duhan sir, Area General Manager Nigahi, who is going to be the Director Technical of CCL. मैं बार बार बोल रहा हूं, तालियां नहीं बज रही हैं, काइंडली तालियां बजाते रहिए. So we will be having this session as we are running a little bit late. We have requested our authors to kindly keep it short. Let's have 20 minutes each session. Sir, thank you everyone. Over to the chairman of the session.
Hello. Good evening. As We are already late. We'll start straightway with Subhajit Banerjee sir. The first paper, Improved Resource Management, ERP Solution for Sustainable Mining. Ten minutes, sir. Try to finish within 10 minutes.
Yes, sir. Good afternoon, सभी को नमस्कार. Sorry, मेरा थ्रोट थोड़ा दर्द है. हाथ कुछ भी नहीं है. I am being guided to them. There is a stringent requirement of shortening patient. I try to do my best. It has been a long time, 10 years now. This morning, during the inaugural session, or if I look back on the focus of this event, ICOMS 23, first word is our second demand supply scenario. So it is all about resources. How do you use your resources to the fullest, preserve them for the future, as well as the introducer has now said, keep on growing economy. Few words from the word cloud. I'll be rushing through the presentation, so please, you'll have to manage with me. Sustainability. How do we sustain this growth? How to preserve resources? How to stop wastage? And of course, digitization of coal mines. First step being DG coal. From 75 to 2023, population, global population has increased from 4 billion, now nearly 8 billion. Per person energy consumption growth is more than 93 times. Do you understand the huge amount of taxation on resources that is happening? There has not been a prolonged period of stagnancy in extraction resources. We, from the global south, there were references to COP28. Global south energy needs energy for growth. In spite of being declared the dirty fuel, 54% of the greenhouse emission gases is on account of oil and gas. Coal can be apportioned only around 40%. EU, as it's evident to all of us, this war between Ukraine and Russia, sorry, the other way around, 60% of EU, 70% of US runs on oil and gas. Still, coal is the dirty fuel because global south needs it. Water. CMD NCL mentioned water as a key resource. 1/4 of the 500 largest cities are water stressed. 33 countries face high stress of water. More than 1 billion have inadequate water. They have to walk for 3 hours or more for drinking water. All from the global south. An American individual uses up 176 gallons of water per day. Whereas An African family uses just 5 gallons. See the dichotomy. Energy consumption. High income countries use more than 60% of upper middle class countries and 13 times more than lower income countries. So, need of the hour, better utilization of resources. You all are aware that ERP has been introduced in Coal India and its subsidiaries. So now we have a basic structure where visibility of resources that are required to run this organization is available. Once there is visibility, एक बार आप देख पाएंगे कि रिसोर्सेज क्या है, तो आप उसे उचित तरीके से या बिना नष्ट किए, बिना वेस्ट किए हुए उसको बेहतर यूज कर पाएंगे. What is ERP? ERP is a digital platform where you can integrate all the resources required to run this business organization. So I'll just show you, or these slides will actually show you what is the live information that is available to you. Anytime an entry is made, irrespective of the production, dispatch, we are showing a few parameters out here. This basically the screen meant for Chairman Coal India to have a glance at production that is taking place, dispatch, capex, and monitor projects worth rupees 400 crores and more. This screen refreshes every 10 minutes. We did 700 million tons last year. As soon as data was entered or confirmed in a shift, this screen in ERP flashed this message of 700 million tons production. So this is the visibility that you gain out of it. Dispatch. As soon as certain activities are confirmed, it is available to you to see what is the status. Tracking of mining projects. We need to do some capex. We need to sustain our growth. Therefore, how do we sustain this growth? But only by looking at progress that we are making. Equipment population. One of the requirements of maybe every area general manager, and one of the answers that used to be available in pockets. Now it is available on the screen. So you can possibly at the level of an area or above it, subsidiary can take a call on what you are going to do with the equipment. Material management. Lots of issues. Now that material management, you all understand, it occupies a bit of space in all modules. There are lots of things associated with materials management, which is available to you on your screen. Consumption, what is the status? Inventory, what is the status? The manpower status, manpower that is available with you. You can add to this basic screen by adding skill sets of human resources that are available. More so required because human resources or salary and wages eats up more than or nearly 50% of the production cost of coal in Coal India. So this is a major concern. How do we best utilize the human resources that are available? This is a glance of electricity consumption. You will see out here that we are paying a penalty for not utilizing the contractual demand of electricity. Higher number of bills compared to a contractual demand is only 3.6, whereas 802. We can't be wasting money on this. Then comes the issue of standardization. During my tenure in internal audit of India, I had to visit several subsidiaries and areas across subsidiaries. I felt as a maintenance that the same equipment was not being handled in the same way across all areas. What to talk of subsidiary to subsidiary? Even within a subsidiary, it was different. Now, with ERP, standard procedures for maintenance, standard procedures for PO, that is process orders for production, is available to be implemented across all areas and mines of. Similarly for material standardization. The third aspect which I would rush through rather, the integration between different modules. Find that every module uses up. I have given you examples of maintenance module and materials management. However, you'll find that every module is integrated with each other. Be it production is integrated with PM, that is maintenance, HCM, human resources, finance, materials management. So, if it is integrated, you are able to fetch integrated reports as well. The clarity in front of you with integration of different resources is immense. Before I get a second bell, the PowerPoint consists of several other slides in which samples of standardization is available. I'll just draw your attention to one slide, integrated reports. This is a sample of a report of a few excavators, specifically of HCL. So this report I doubt being used in HCL. Find that along with the parameters of equipment, the production values are also coming in. So at the level of a area general manager, you can very well understand which machine works out best for you and where. ERP has been promoted as the single source of Ekam Sat Vipraha Bahut Vadati. With this single source of, now it is the opportunity in front of us, leapfrog into a better tomorrow, sustainable tomorrow, by use of AI and ML. Thank you. I hope I have honored your
Yeah, thank you, सुभजीत बनर्जी साहब. काफी डिटेल और इन डेप्थ आपका डाटा एनालिसिस था, काफी इंटरेस्टिंग डिटेल्स. सभी डेफिनेटली बुद्धिवर्धन हुआ होगा और यूज भी करेंगे जो आपने लास्ट में मैसेज दिया है. इसके साथ ही में नेक्स्ट जो हमारे ऑथर हैं डॉक्टर सौम्य रंजन मलिक साहब, असेसमेंट ऑफ एयर क्वालिटी इन रेजिडेंशियल एरियाज।
There is a
that chair, rapporteur, and distinguished author, the dais, executive of NC, distinguished delegates and organization abroad, distinguished authors for this. I am thankful to NCL for present. This is a BTech paper done by graduate students of government, guided by me. As far as the research area is concerned, my research area is always pavement design. Why I am saying? Because as far as the dust generation is concerned, or mine dust is apart from drilling, casting, then crushing. The as far as the all road is concerned, subsidiaries of India Limited. आज have amount of fine over line. Therefore, not dealing overburden material. The overburden material affects the headers or complex. That is not the actual make a requirement. And why I am not preparing it requirement post due to trend of all trust that's generated and this food surface is not that much. Then at every place of spillage, and that spillage of material will get the why I am saying thing is that the demand as far as power requirement of India is concerned, and as far as as far as 60-70%, and as far as thermal power is concerned, the fossil fuel or and right, and आज जब till this part full generation is day by day, and it 1000 I think 24 or 20. आज the full capacity full generation is also day by day, not in day by day.
Dr. Soumya Malik, please come to this. Come to the subject. Focus on the.
See that dust is generated and has to and case study Jagannath and have tried the characterization of as far as the size is 2.5 micron, 2.5 micron particular matter, and 10 PM10 and next. As far as the adverse impact is concerned, can be if minor or static, we can track this next slide. As far as the standard is concerned, air standards, these are the standards but as far as area is concerned, there is still next slide. As far as the data is concerned, uh, uh, as far as some of the some of the days there is a sharp and sufficient that is different movement of and uh, 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 on those days water was then on some of the days are there. As far as the discussion concerned, so if particulate matter is there, as far as the activity is concerned, that, that is blasting material, whether that is liberation of material, highly concerned, that practicable and we cannot restrict that. So as far as coal mining concerned, for development, have to extract the overburden. We have to come. So dust will. Is there any practice or apart from separation of dust, butter? Because most of the some of the area butter gets it, and as far as commerce is concerned, is not at the end of companies is the dust with butter, and main demerit with separation of dust butter that it can dampen it, can suppress the dust for some time, and after some time when moisture or the water, then that will be airborne once again. So, is there any format or can we use some agglomerating agents or agglomeration so that it will be last for long and the dust that is generated due to different activities, as I said, transport, etc. Can it as far as we have recommended, but that is not yet approved for moving agent, and what is the mechanism that is agent or chemical that is reducing some, and it can form bubbles and it can attract us. As far as it is concerned, we have used oil like palm olive oil is there, then soybean oil is there, then deionized. Then we have made some combination. Then collected some algae from the pond and lake that we can add them, and as far as the algae is concerned, it has hardly any adverse environmental impact. Tried to make agglomeration will have very less adverse impact on environment, but that is approved by the or appropriate authority.
And as I said, has adverse impact as far as the mine dust is concerned. Also, the corrosion of maybe after or whatever machines that is deployed in mine, corrosion is there. Have to address it as far as occupational health hazard is concerned, as far as long or heavy task that is deployed in the mine is concerned. So have to address as far as uh, cannot do have to the size reduction in every phase, particular pattern there, and that will put yes, and how apart from the dust separation, how we can make the agglomeration with the chemical commercial additive that is available in the market with very less fat environment. Very
Thank
much
you.
for giving the
Thank you, Dr. Soumyaranjan. Study of MCL can be useful for CL also. Now I call our own दीप कुमार त्रिपाठी साहब, जो प्रधानमंत्री का जो सपना है 5 ट्रिलियन इकोनॉमी, उसमें CIL का कंट्रीब्यूशन है. प्लीज.
First of all, good afternoon, House. Today, there are a few buzzwords. One is 5 trillion economy, Atmanirbhar Bharat, green policy, full-friendly mining, efficient and economic mining. These are the buzzwords. So I will start with 5 trillion economy, Atmanirbhar Bharat, because India is now the largest, just behind US, Japan and Germany. $7 trillion. Have to go along with sufficient 5 trillion. Next. You can see we have three scenarios. This has ambitious scenario and highly ambitious. Business as usual, as we are doing same pace, continue, then where we are going. Whereas ambitious scenario caters to the ambitious development targets of the government, the energy will achieve 175 gigawatt renewable energy target, whereas the other targets are hit on the basis of project and pipeline. It is achievable. Whereas highly ambitious scenario is all the targets of that is gigawatts renewable energy by 2030, 30 gigawatt of offshore wind, 22.48 gigawatt capacity addition. There are the targets. Cleanest and the most pure energy scenario. India achieves the target of 5 trillion economy by 2025 in this scenario. Results change of demand activity, energy demands, thus changing the supply scenario as well. So this is the background behind our strategy, and you can see on the screen the CAGR. If you grow the 8.6% in highly ambitious scenario, by doing that we can achieve accordingly the plans are made. Next. You can see the power required. Presently, again, these three scenarios have been shown. We can see that from 1656, we have to reach 434 gigawatt, whereas from 1676, 4728, and from 176307. So power requirement is going to increase next year. Now we see the coal requirement. When we see the business as usual and ambitious scenarios, the coal production, the figures have been taken from 2022 onwards, 1072 including ports, 1533 billion, and that is 1.53 pt. And in highly ambitious scenario, it reaches to 1.876 billion tons. Next. The percentage of coal in energy scenario, as it is reducing in scenarios ranging from 65, 61%, 30%, 36%. It is ratio, the scenario, the share of coal energy sector is decreasing day by day, but at the same time, the coal volume is certainly going to increase. And that reminds me of the inaugural session. Lisa was saying that even beyond 2007, by 2015, we will be needing and at a higher level because actually, just because we do have a strong foot, we are the fourth largest coal reserve of the world. Definitely, we have to rely on it, irrespective of other targets. Yes, other targets have to be met, but coal consumption will. Next. Here you can see all scenario requirement, all the scenarios increasing progressively. Coal requirement is in all the three scenarios increasing progressively. However, the energy mix is changing. Percentage of coal in all the scenarios is declining progressively. Next. Now, the driving elements guiding CIL energy, 5 pillars of monitoring that leads to demand and supply scenario. The world-class infrastructure, system-based technology, the skilled demography that will take us to 5 trillion. Then PM Panchamrita strategy has been talked time and again in previous sessions, whether it is 500 gigawatt by non-fossil resources or 50% by renewable energy resources by 2030. Again by 2030, the carbon emission has to be reduced from 3 gigatons to 2 gigatons. Again by 2030, the coal carbon intensity has to be decreased by 45% for the 2005 levels. And ultimately, have to touch that next scenario by 2070. That's the guiding. Again, PM Gati Shakti program, infrastructure, technology, and coordination at higher levels so as to give an integrated scenario. Industry 4.0, we are already ushered into an arena of Project Z Code, where through use of 13 use cases, we are trying to leverage the advantages of Industry 4.0 so that we can economize, we can make it efficient, and can make it people friendly, and above all, the management will be able to take informed decisions, SWOT analysis and resource technology. Next. So we come initially, we have divided the entire CIL strategy into two parts, one for short term, that is 1 BT, and then another long term. For 1 BT, we have 4 elements, land and R&R, then statutory green clearances, forest clearance, and environmental clearances. In R&R, we have compensation, resettlement, and rehabilitation. Infrastructure, railway lines in form of FMC projects, PHPs, silos, rail connectivity. So, by means of FMC projects, NCL going to increase its evacuation from 68.5 million tons initially to 125.5 million tons, whereas Coal India is going to increase it from 51.5 million tons, 41 million tons. So that's the future vision from where we can go ahead. And then project and planning, including geological reports as well as project reports. Like we are already going to achieve 137 million ton production in northern coal limited, but at the same time there is a threat also that mines like Jhinguta, Kakri, they are going to take a backseat, and ultimately we have to cope up the production from the main basin, and we are already in the process of some GRs have been completed, GRs are in the making, and a master plan is going to be made for main basins so that we can rid up the production that is lost from here and go ahead so that we can suffice the energy requirements to our present customers. Next. Reduce imports. This is one of the biggest dreams. We will be talking about how we can reduce, focusing in what areas we can reduce the imports. Because right now, since last 2-3 years, we have been in the range of 200 billion tons imports, and that is costly, especially. But definitely, non-coking coal area we can definitely make on. However, in coking coal area, there are a few issues. At the same time, we can think of making a steel non-coking coal also. That avenues have already been searched in by Jindal Steel, at Angul, and they might be replicated at other places depending upon the success and the. Then even we are still exporting coal to other countries, and that especially Bangladesh and Nepal, Bhutan, etc. And if need comes and we suffice our domestic demand, definitely we will be in a position to export to the foreign country. Infrastructure for coal dispatches, diversification. As you know, diversification has been talked a lot about, so I won't go into detail of it. But definitely, for NCL scenario, I must say that we have our present requirement of 273 megawatt. We do have already functional 470 kilowatt peak at the Jayanth, that is rooftop. Then ground mounted 50 megawatt is almost complete, 97%. And we have already signed an MOU with the PJV JNL for 250 megawatts. So definitely we will be achieving net zero much before full India and much before India does it. So we will be a flag bearer in the entire industry to achieve net zero. Then monetization of assets is, it is a public private participation where ownership of the mineral lies with us, and we give that block to mine through a bidding process. Like surface coal gasification, railway sidings, crops and barren land or revenue sharing, and MDO. You can, the CRBL project, the first MDO project of Coal India, has already become functional with a normative capacity of 40 million ton and a peak capacity of 50 million ton. Next, please. Next. No, previous slide. You can see this I have already talked about. The likely investment ending financial year 2024 is about 17,000 crores on MDO and 15 greenfield projects spread through MDO model. However, one has been cancelled. Next. This is reduced imports by import substitution, focusing on mines near sea coast, international border. That does mean that WCL and Mahanadi coal position to usher into that zone. Focusing on non-coking, as I have already explained. Infrastructure from mine to shipping point, this is one important point, and this has formed the component of Gati Shakti also. Agreements with importers, stakeholders to substitute high-cost imports by cheap domestic. That's already going many phases part by part. Next. Diversification towards green energy. Setting up of SPV by CIL for solar module manufacturing value chain. Setting up of SPV by CIL for setting up aluminium plants in Odisha and Jharkhand. Setting up of SPV by CIL for aluminium smelting out with NALCO. R&D projects on coal to sand. You can see the rooftop, ground mounted, the floating, and our new initiative, green initiative, which will definitely maintain the riverine ecosystem. Sand, manufacture sand from next. Monetization, we have already talked of. These are the next. Next. So that's all, and this definitely drives me to put a couplet from Vajpayee. हार नहीं मानता, रात नहीं ढूंढूंगा, काल के कपाल पर लिखता मिटाता हूँ, गीत नया गाता हूँ. थैंक यू.
गीत नया गाता हूँ के साथ प्रधानमंत्री का सपना है, उसको कैसे कोल इंडिया और एनसीएल पूरा करने जा रहे हैं. प्रदीप कुमार त्रिपाठी साहब ने बहुत ही सरल तरीके से बताया है और अवश्य ही इसको पूरा करेंगे. शानदार.
थैंक यू सर. चल मंडेरा ने कहा था, इट ऑलवेज सीम्स इम्पॉसिबल अंटिल डन. एंड 5 ट्रिलियन इकोनॉमी जब प्रधानमंत्री मोदी ने पहली बार कहा था कि हम इस पर्टिकुलर ईयर तक अचीव कर लेंगे, तो आधे कॉर्पोरेट्स कह रहे थे इट पॉसिबल. बट वी आर ऑन द ट्रैक, एंड आई बिलीव energy sector, in particular coal mining, is going to be one of the biggest driver to make India Atmanirbhar, and import substitution can also be ensured. Now, in order to proceed further, I would like to request our chairman sir to kindly felicitate Subhajit Banerjee sir for his presentation. Backstage team kindly. Our chairman of the session, Sri Harish Duhan sir, felicitating Subhajit Banerjee sir, GMERP, for his paper presentation. A round of applause, please. I would request co-chairman of the session, Sri Deepak Saxena sir, to kindly felicitate Dr. Soumyaranjan Malik sir. I would request Sri P.D. Rathi sir, GM Block B, to kindly felicitate Sri Pradeep Kumar Tripathi sir. Moving further in the session, now I would invite Sri Jitendra Kumar Dikshit sir and I would invite Sri Jiten Kumar Dikshit sir kindly come on stage, take the author's seat. I would invite Dr. Sonal to kindly come on stage to take the author's seat. We are running out of time, so we will make it quick as soon as possible.
Fourth paper is in study of high pressure dust suppression system in CHP Opencast Mines CIL. Mr. Jitendra Kumar Dikshit.
Hello. Good evening to all of you. So, first of all, thanks to NCL inviting me. Now, I have started the topic is high pressure dust suppression system. First, the main part of the any CHP is dust suppression system. But sometimes we are ignoring, because we are thinking that our production is going on, dispatch is going on, so no need to take care of dust suppression system. But dust suppression system, the auxiliary system, the most important. So, next slide. The dust suppression system, in generally, we have taken a lot of places where we are using dust suppression system, but I am concentrating only transfer house in coal handling plants, or what is the discharge point, we are using dust suppression system. So you know, we are working in the mining industry, so dust is the prime source of in every operation you can see dust in coal mines. This is the major challenge for mining condition. How can we suppress the dust, and how, because it is going on. If you see the coal mining in before 30-40 years, we are still improving the dust suppression. But nowadays, if you see, lot of types of dust suppression is there. Like initially we are using plain water dust suppression system. After that, you see dust collectors, then dry fog dust suppression system. But now we want to improve, because the demand of the time. Because if you see the improvement, the time will come, then the things are improved and technology also improves. So nowadays we are using high pressure dust suppression system. Next. Before you start the dust suppression system, you should know next. First you see previous. See what is the dust suppression system contribution in all over the mines. You see the maximum dust is used in all road. But I am concentrating only CHP, coal handling plant. In coal handling plant, around 10% dust is there. So in my paper, I am concentrating only coal handling plant. Next. So for dust suppression system, the objective of the system is the system should be health and safety requirement. It is the simple in operation. The initial cost shall be low and operation cost also low. And last one is there is no adverse effect of quality or plant, and machinery should be created. Next. Now before I start the SPDS, I just share
one schematic diagram of coal handling plant. I think most of the aware for what is the coal handling plant. If you see in coal handling plant, we have start from track receiving hopper. When coal will come, then it discharge to the through vibro feeder, discharge to the bed conveyor. After the bed conveyor, one transfer house is there, or it depends upon the situation. Sometimes more transfer house is there. After the transfer house, one triple conveyor is there. In triple conveyor, if you see, the one bunker is there. Bunker is two types. Sometimes bunker is vibrative feeder is there below the bunker. If bunker is capacity is less, sometimes we are using plough feeder and bunker capacity is more. After the plough feeder, you see the reclaim conveyor is there. The reclaim conveyor goes to the silo loading point. So in this CSP, you concentrate the discharge point. If you see, first discharge point is through vibratory feeder. In vibratory feeder, the coal will discharge to the conveyor. Second discharge point is transfer house. The third one is triple conveyor. The fourth one is below the bunker, plough feeder is there or vibro feeder is there. The last one is silo loading conveyor. When we loaded the conveyor to the silo, we need some soot is there. So that place also we require some dust suppression. The last one is wagon loading is there. So all the places, dust is the prime source. So we need to require how can we rectify the dust and suppress the dust suppression. Next. Now comes to the type of dust suppression system. If you see in generally the receiving pits, we are using two types of dust suppression is there. One is plain water dust suppression is there, and second one is fog cannon. Fog cannon is now we are using, and we are planning also as a CMPDI. We have given in some MCL mines also. In one mines is Tadega mines is there, and one Lachkora mines is there, where we are providing the fog cannon. Initially, plain water is given in all the mines of Coal India. And second one is high pressure type DS. You see vibrative feeder, oil transfer point, plough feeder, silo top and wagon loading. We are providing high pressure dust suppression system. Now comes to the what is the high pressure dust suppression system? Because if you see the term says high pressure. High pressure means in this system the pressure will come around 70 bar. 70 bar is there, and water consumption is very less. And the HPDS system, lot of filter is there. The main important thing is the heart of the system is RO water. We are using RO water to eliminate the nozzle choking and scale formation of the dust. And next one is we are reducing the hardness. So that's why the scale formation is very less and the life is more. So 3 to 5 years there is no need for maintenance. And second last thing is there in every dust suppression system we are using two pumps, one working and one standby in all the systems. Next. Now comes to the what is the component of the SPDS. First component is feed water pump is there. When the water is supplied to the RCC. RCC one water tank is there. After feed water pump, one filter arrangement is there. In filter arrangement, there are two types of filter is there. One is multi-gate filter and second one is carbon filter. After the filtration, it will go to the RO pump. One RO pump is there. When some water is rejected and some water is just treated water. After the RO pump, one booster pump is there. Booster pump, with the help of this pump, the water with treated water goes to the high pressure pump. After the booster pump, one high pressure pump is there. That is called SPDS pump. In SPDS pump, we can generate the pressure of 70 to 75 bars, and the nozzle is stainless steel tubes is there, and that is created the fog. So nozzle is SS steel, so that's the life is more. Now comes to the layout. What is the SPDS system is there? First, one RCC tank is there. When the water is storage, after the RCC tank, one feed water pump is there. After the feed water pump, there are the filters, multi-filter, multi-gate filters and carbon filter is there. After the filters, RO pump is there. In the RO pump, we can use the water for two ways. Sometimes around 50% water is rejected and 50% water is treated. Sometimes it is 30% also, and we can use rejected water is in service water also. When cleaning the equipment, we can also use it or it will drain. The treated water, first bit it will go to the PVC tank when water is storage. After the PVC tank, one booster pump is there and water is fed to the reciprocating pump is there where the pressure is 70 to 70 bar is there. After the reciprocating pump, it will go to the dust generation point is there Basically, destination point is I already discussed vibrative feeder, transfer house, and silo is there. Next. Now this is the schematic diagram of HPDS system. What we have studied. If you see the NCL or MCL or SCCL, we have already implemented in this FMC project. We also try to develop this HPDS system. This is the just one PNID diagram is there for HPDS system. Next. The just one diagram. Next. Now comes to the what is the effect of HPDS system before HPDS and after the high pressure disturbance system. Just show the video on the video, both the video. Video is there. Back. Just below. Yes. This is the before the HPDS system where there is no HPDS. If you see the lot of dust is there. This is the conveyor in plough feeder. If you see the plough feeder, this is the situation for dust. Then go the second one. When HPDS system is there, it's very smooth because dust is the major thing. Environmentally also because the peoples are observing lot of problem is there like asthma and all the diseases there because of dust. So first we will take care of the dust using the HPDS system. Next slide. Now I'm just say a little bit about the dry fog system because initially we are using dry fog disturbance system and HPDS is replaced. If you see the DFDS system, we are using basically in DFDS system what is the problem is there, we are using two components. One is air, one is water. When we mix the water and air through the compressor, then we will find out the dry fog disturbance system. Next. This is the schematic diagram of DFDS. One water tank is there. The only difference between DFDS and HPDS is there. In DFDS, our requirement is more because we need two compressor extra, one working, one standby, air receiver extra, plus we need two types of fluid. One is air, one is water. When we mix the air in water, then we can find out the dust suppression in DFDS. The cost is also more. The major thing is there, the pipe is MS pipe. So scale formation is there and choking problem is there. But that's why we are not using now DFDS. Next. This is a little bit we have discussed. How can we discuss between HPDS and DFDS? I am just discuss only one part. You can increase the part also. One DFDS if you see. Next. DFDS and HPDS you can find out on through the compressor the air is extra part is there. So that's why the power is more. Next. This is the HPDS pump. If you see all the pumps, around 12 kilowatt is there for all the pump, feed pump, RO pump. Next. This is the motor selected for all the pump. If you see the reciprocating pump, around 46% is consumption through reciprocating pump. Otherwise, all the pumps is very less kilowatt. Next. If you see the comparison between HPDS, you can find out in dry fog system the kilowatt is around 12 kilowatt is there. But if you see the dry fog, the power is around 22 kilowatt. Next. This is the comparison between HPDS and DFDS. I already told the power consumption is less because of compressor is not there and the water consumption is also low. So this is the comparison between HPDS. Come to the conclusion. Basically, we are using HPDS because of three things. First one is the power consumption is less compared to the DFDS. The second one is project cost also. If you see the electricity consumption, around 60% consumption is less if you are using HPDS system. The third one is project cost, which will reduce 10 to 15% because the civil cost is more in DFDS and lot of piping is there. So DFDS more costly compared to the high pressure disturbance system. Last one is the hardness reduced, so that's why scale formation is less, life is more. So as for the CMPDI is concerned, we are recommended also HPDS is better technology and maintenance is also less. So for the mining industry, HPDS is the better technology compared to the any other technology. Thank you, sir.
Thank you, Mr. Jitendra Dixit. We can change this system in the existing coal handling plants also. They are very useful. Now I call on Dr. Sonal from CMPD at Varanasi for sustainable mining, AI application for environmental impact mitigation and resource conservation.
Good evening, respected session chair, the delegates, participants, and the audience. I am Dr. Sonal, PhD from VIT Mesra, currently working as Assistant Professor in Sarla Birla University, and my co-authors are Sri Rajesh Kumar and Sri Vishant Rishabh from CMTTI Ranchi. The title of my presentation is Sustainable Mining, AI Applications for Environmental Impact Mitigation and Resource Conservation. This topic is about examining the specific AI application for environmental impact mitigation under different mining related activities using the machine learning algorithm and multi-criteria decision making so that the whole system can be changed for more sustainable one. Next. Situational awareness is the perception of elements in the environment within a given time and space, comprehension of its meaning, and perception or projection and prediction of its status in the near future. By integrating all these components, the whole system is converted into a system that is aware of its environmental impact as well as it is capable of self-adjusting and thriving in the face of uncertainties related to environmental impact. Next. Artificial intelligence applications play a pivotal role in achieving these aims by utilizing the huge data sets, its analysis, fusion, and predictive modeling so that the system can be discretely modeled into a time-varying system and its near future prediction can be determined. Next. Hence, the objectives of my research work. The first objective is to examine the existing AI applications in the mining sector. The second objective is to identify the gaps and challenges. And finally, the third objective is to propose recommendations and pathways for maximizing the effectiveness of AI in achieving environmental sustainability and resource conservation, specifically in Opencast mining. Next. The environmental degradation is not a static one. It changes with respect to monthly and seasonal variations. In order to determine these uncertainties, the traditional probabilistic approaches are insufficient since it is uncertain as well as non-deterministic in nature. So in order to capture the time-varying environmental impact, the dynamic Bayesian network concept is also in order to optimize the optimal mining related activities along with considering the environmental impacts, it is important to determine the impact assessment. For that purpose, resiliency is determined. As we can see from the slide, resiliency is inversely proportional to the performance loss, where R is resiliency of uncertainty related to environmental impact. Next. There are various methods for which uncertainties can be captured. Some of them are the sequential data modeling and time series modeling. Also, there are some classical approaches like ARIMA and RMAX. However, these approaches have some disadvantages, like the prior knowledge cannot be incorporated easily, and also the multidimensional input and output are difficult to monitor. For that reason, the latest one, that is dynamic Bayesian network, is implemented. As we can see from figure 3 mentioned on the slide, we have on the left hand side, we have a system where the environment related factors are denoted by the nodes and the arcs represent the conditional dependence. According to the monthly and seasonal variations, these dependencies also change. So we can see at time t plus 1 and t plus n, these dependencies are marked by dashed lines and some dark lines. Sorry. So in this way, the uncertainty can be modeled. Sorry. The basis of my work is Bayesian network. As we can see, the concept of Bayesian network, it is a mathematical modeling concept where the factors of environmental degradation are represented by the node and the arcs represent the conditional dependence. For example, the environmental impact is determined majorly by the component related malfunction and the waste management. So all these will have some conditional dependence in them, which are represented by the arc as shown in the mentioned on the slide. Next. Now, converting this Bayesian concept to a time-varying system, we have the dynamic concept, that is dynamic Bayesian method. Here we can see that at any time instant, the random variable at any time slice can be conditionally dependent upon their parents at the same time slice, as well as and their parents at the previous time slice, represented by equation 1 and 2. And for all the different nodes that represent the factors of environmental distribution, the joint probability can be found as shown in next. Now we have taken this data from CM2. These are the major factors account for environmental impact. It can be majorly classified into malfunctioning of component and situational awareness. Further classifying the situational awareness, we have environmental constraints and the time variation. Under environmental constraints, we have the terminal nodes like biodiversity, adaptive management, waste management, regulatory frameworks, ecological life cycle assessment, recovery and dependency, component age, component malfunction. All these data, all these linguistic variables need to be converted into data. And for that purpose, we are using dynamic Bayesian and machine learning algorithm in order to quantify all these terminal nodes that are actually qualitative in nature to quantitative form. Next. For 24-hour time variation, this in the previous slide, the modeling is simulated for 24-hour duration. However, for simplicity, a 3-time slice modeling is shown where the node P shows the joint probability of factors and node Q is the observation state. So we can see at time minus 1 and T plus 1, the observation of environmental impact, somewhere it is 11%, somewhere it is 12%. So in this way, if we have situational awareness integrated into the system, that real-time variation of environmental impact can be determined. Next. This slide summarizes the steps, that is to analyze the cause of environmental impact related uncertainties of Opencast mining. Firstly, we are modeling the system into a dynamic one. Then we are listing the hierarchy in criteria, sub-criteria and alternatives. Then these qualitative measures are converted into quantitative one by using the pairwise correlation between all these factors. And lastly, the eigenvectors, eigenvalues are calculated, meaning that the consistency index is better. This consistency index further for different size matrices, the consistency ratio can be calculated. Consistency ratio less than 10% are taken in our analysis because that takes into account all the different types of randomness that is encountered in the environmental related uncertainty. Next. So as demonstrated in the previous slide, we have the terminal nodes which are demonstrated as the parameters. These parameters are related to each other in a linguistic term. In order to convert that linguistic term into mathematical form, triangular fuzzy scale and triangular fuzzy reciprocal scale are used. Fuzzy analytical hierarchy process is used to find the different correlation between the terminal factors of environmental impact, and according to it we have matrices shown by A and B. The corresponding eigenvalues and consistency ratio are also shown in the diagram. The nodes we can see where there are some nodes where it is marked by red arc and some are marked with gray ones, and there are also thicker nodes in. The thicker nodes denote that the time variation has a major impact in the environmental impact related to mining related activities. Other than that, all the red denote they are equally important in environmental impact model. Along with it, regulatory framework is having an impact. Next. All these data are taken and are incorporated into a machine learning algorithm, that is unsupervised learning, that is HMM, hidden Markov modeling, where we do not know the factors but the observation state we are aware of. So this is the time variation of the strength of influence of different environmental impact related factors. Next. Based on that, specific AI-based applications are addressed. These are AI-based remote sensing, machine learning for modeling the environmental impact, then smart mining operations specifically oriented at resource extraction, and the last is AI-driven efficient energy management. Next. I would like to conclude by mentioning that the real-time monitoring is essential of these non-deterministic resiliency, so that the determination of these qualitative aspects also need to be incorporated into the quantitative measures for a very pinpointed key factor contribution of opencast mining related uncertainties and its deterrence from the behavior. Next. These are the key references. Next. Thank you.
Thank you, Dr. Sonal. You have just given an overview how AI can be used for environmental impact mitigation. Thank you.
Implementing environmental management strategies is not a choice between profit and preservation. It's harmonious blend of both. Our action today ripple time, affecting the interconnected web of life, and hence environmental management is a very vital constraint that mining industry needs to meet. With this, we have completed our technical presentations. Now what I would request technical chairs, starting with rapporteur, to kindly summarize the session.
Thank you, Dinkar. Today's second session, technical second session, I greet all, evening, all the dignitaries, authors on the dais, and all the delegates and dignitaries of the dais. Today's sessions, we had 5 papers. The 5 papers based on the theme and our problem statement of ICOMS, technology-based environment management and resource planning. First paper was presented on improved resource management, the ERP solution for sustainable mining by Shri Subhashit Banerjee Sahab. He is a GM ERP CIL. He very eloquently described and deliberated how resource management is critical to sustainability. What are different resources which are critical to our national energy matrix, and how these different resources are played in global energy politics. In this context, now what is the role of CIL in managing these resources, and what is the strategy? Now we have implemented the ERP with 7 modules: the finance module, personal module, marketing and sales module, production module, materials management, project management, and plant and maintenance. So the impact of these implementation of these modules is the visibility in managing the resource, monitoring, control, informed decision making, standardization, and this will make the life of decision maker or management process very easy on day-to-day basis. So thank you, sir. This was very nicely presented paper which is under implementation across Coal India. Now assessment of the second paper was assessment of air quality in residential areas around an opencast mines, a case study by Dr. Soumya Ranjan Malik, GEC Keonjhar. The study was carried out in Jagannath area of Mahanadi coalfields in financial year 18-19 for 1 year. PM 10 and PM 2.5. He has described the parameters which have impact on the dust
dust pollution, specifically the sources of dust pollution and mitigation measures. He has given some critical measures which includes housekeeping, blacktopping, and use of binding chemical agents, agglomerating agents, and foaming agents. So this was very practical approach based paper. Third paper was based was CIL strategy in contribution for 5 trillion economy, Atmanirbhar Bharat, by Shri Pradeep Kumar Tripathi, Corporate Planning Department, NCL. He very nicely, in simple words, presented different scenarios, that is business as usual, ambitious energy scenario, and highly ambitious energy scenario in the energy space targets till 2047. He briefed about how ambitious scenario of 175 gigawatt RE and highly ambitious scenario of 450 gigawatt of RE having aspirational targets of 8.6% CAGR, and what is the role of coal in this into achieving these targets from 1 billion to almost 1.8 billion. And in the vision of our Honorable Prime Minister, the different pillars of economy, how he tried to correlate all these pillars of economy practically in what actions we are taking in Coal India to achieve those goals which lie in our domain, that is reducing the imports, export of coal, FMC project, infrastructure development, diversification, solar, thermal power plants, sand, silica, and monetization of assets. And it was very brief and very nicely presented paper. Thank you, Mr. Tripathi. The fourth paper was study of high pressure dust suppression system in CHP of Opencast mines in CIL by Shri Jitendra Kumar Dikshit from CMPDA. He described and explained the process of coal flow in CHP and the sources of dust, and how these sources of dust can effectively be suppressed with the help of fog cannon and high pressure types of dust suppression systems, which is having more than 70 bar pressure with RO water. And he again compared this with dry fog dust suppression systems, and he explained how these high pressure dust suppression systems are economic, effective, and having more life with less maintenance, requires less maintenance. So this will give a good understanding of this high pressure dust suppression system to our engineers. Thank you. And the fifth paper was sustainable mining AI applications for environmental impact mitigation and resource conservation by Dr. Sonal. She has given how the situational awareness, which consists of perception, comprehension, and projection, can lead to decision and action, and how out of these feedback can be generated and the process can be improved. And in this process, what can be the role of AI, that she has deliberated in detail. And the objective of her project was to identify the applications, what are the gap in the existing models, what are the challenges, and what can be the recommendations. She has deliberated what are the limitations of the classical and other available models at this point of time due to the nature of dynamic uncertainties and complexities in the mining system. She has given the Bayesian network concept, explained, and how this can be used in simulation using machine learning. And she has given deliberated what are the applications of this AI based system in remote sensing, production management, energy management, and other management business processes in mining industry. And this is all about today's technical session, but I have briefed. All the 5 papers are very relevant to the theme of the ICOMS, and I thank you all the authors for enriching with their knowledge. Thank you.
You, sir. I would request co-chairman of the session to summarize.
थैंक यू मिस्टर राठी। सर ने तो सारे पेपर्स, 5 पेपर्स का बहुत डिटेल से एनालिसिस कर दिया है, फर्दर बहुत कुछ ऐड करने को नहीं है। पहला पेपर बनर्जी सर ने टीआरपी पे दिया था कि कैसे हमको अपने रिसोर्सेज को आइडेंटिफाई करना है और रिसोर्स को आइडेंटिफाई करने के बाद हमको कैसे इंटीग्रेट करना है और फिर डिजिटल प्लेटफॉर्म में लेके आना है। सीआईएल में हम लोग ने ऑलरेडी ईआरपी इंट्रोड्यूस किया है और वो सक्सेसफुली चल रहा है। हम लोग के लिए, सबके लिए एक अच्छा एक्सपीरियंस था उस पेपर को देख करके उससे सीखने को। प्रोफेसर मलिक ने और दीक्षित सर ने, इन्होंने जो प्रेजेंटेशन दिया था वो डस्ट सेपरेशन पे था, दोनों का एरिया अलग अलग था। आपने सीएचपी में जो डस्ट जनरेशन पे दिया और डॉक्टर मलिक ने जो माइंस में पर्टिकुलरली हॉल रोड्स में था उसके डिफरेंट कैसे कैसे डस्ट जनरेट होगा और कैसे हम मेजर्स लेंगे उसको कंट्रोल करने के लिए, उस पर पेपर दिया। काफ़ी इंफॉर्मेटिव था, हम सब के लिए बहुत यूजफुल भी है। हम लोग हाईली मैकेनाइज्ड माइंस में चलते हैं जहाँ पे हमारी सीएचपीज भी बहुत बड़े बड़े कोल्ड हैंडलिंग प्लांट्स हैं, तो आपके पेपर से हम लोग को काफ़ी मदद मिलेगी और हम उसको इम्प्लीमेंट भी करें, कैसे हाई प्रेशर डस्ट सेपरेशन सिस्टम को हम लोग लागू कर सकते हैं व्हील्स की। मैडम ने एआई का इंट्रोडक्शन कैसे माइनिंग सस्टेनेबिलिटी पे करना है बहुत पेपर प्रेजेंट किया। मैं सारे ऑथर्स को थैंक्स देता हूँ कि एक अच्छा इंफॉर्मेशन हम सबके बीच में दिया और हम सबको अपना नॉलेज बढ़ाने का मौका दिया। दुख थोड़ा सा होता है ये देख करके कि इतने डेलीगेट्स को नॉमिनेट करने के बाद भी यहाँ पे बहुत कम लोग दिख रहे हैं। तो मैं सारे लोगों से जो यहाँ हैं बोलूँगा अपने साथ कोलीग से कि कल ये स्थिति ना आए। थैंक यू।
Thank you very much, sir. Request session chairman comment.
लास्ट सेशन था, हॉल की स्ट्रेंथ को देख के भी लग रहा है लंच के बाद थोड़ा सा दिक्कत होती, लेकिन फिर भी इतनी मेहनत करके इतना यहाँ पे सिंगरौली में ये कॉन्फ्रेंस अरेंज करना, उसका पूरा फायदा हमारे ऑफिसर्स को उठाना चाहिए। मैं इस लास्ट सेशन के लिए अपने को चेयरमैन, अपने रेपुटियर, सभी ऑथर्स को थैंक यू बोलता हूँ कि बड़े ही कंसाइज वे में सपोर्ट करते हुए इसको टाइमली कंप्लीट किया। थैंक यू, थैंक्स ए लॉट।
थैंक यू सर। बड़ी देर में बहुत ही मधुर संगीत, गीत, नृत्य आप सबके सामने होगा, तो ये जो थकान को मिटाने का है, इतना एग्जॉस्टिव दिन जो हमारा रहा है, बहुत ही जल्द ये थकान भी मिटने वाली है। तो इस थकान को मिटाने के लिए एक बार जोरदार ताली हो जाए फॉर दिस एंटायर सेशन। It's time for the felicitation of our authors. I would request session chairman, co-chairman and deputy sir to kindly felicitate Shri Jitendra Kumar Dikshit sir for his paper on study of high pressure dust separation system in CHP of Opencast mines in CIL. I would also request the session chairmen to kindly felicitate Dr. Tonal ma'am. Kindly come up front. I would request session chairman Shri Harish Duhan sir to kindly felicitate Shri P.D. Rathi sir, Deputy of the session. I would request Sri Harish Duhan sir to kindly felicitate Deepak Saxena sir, co-chairman of the session. I would request Professor Debashish Dev sir to kindly come up stage to felicitate chairman of the session. Clap for both. Sustainable mining एक responsibility है and ये responsibility उतनी बारी है जितने कि हमारे द्वारा ये हम कल फिर मिलेंगे सुबह 9:15 बजे से आप सबके साथ टेक्निकल सेशन